Perfect. Thank you so much, guys. I think I'm the last speaker, so I'm not going to hold you back for very long for the happy hour that's coming right after this one. Thank you for staying. I am local here, based in Northern Virginia. So, yeah, last time I was presenting at some local conference, and that's when Gary and I met. So he suggested I should come and present at this conference. Once again, thank you so much. That's my book right there that I published last year. This was about, hybrid cloud. So essentially taking your applications and not getting tied into one or two or any single cloud for that matter, but writing your apps in a way that you can move them around whenever you want, wherever you want, so that you feel in control of your own code that you have wrote to serve your business. Having said that, I'm going to do some level set. First of all, what is AI? Maybe right now, right after ChatGPT came, everybody knows what AI is, right? Artificial intelligence. Everybody is talking about it. There is a lot of buzz about it. It's not like AI is a new thing, but definitely right after ChatGPT, it's everybody's thing. Like starting from school kids to all the way to any organization, any business for that matter. I think there is a big prediction out there from Gartner how Gen AI, especially the ChatGPT was basically Gen AI, right? Generative AI, and that's what created the whole huge buzz. And a big prediction from Gartner is how more than 80% of enterprises will be using Gen AI capabilities. So we will see what Gen AI means, but I want to do some level set here, right? So like I said, AI has been around. There was predictive AI, but then came Gen AI. So we're not going to go through all these line items, but essentially what that means is Gen AI is about generating new content, and that's what created the big buzz. Predictive AI was analyzing the data and look for certain patterns. But Gen AI is essentially, like I said, generating a new stuff from its own creativity. So, a rapidly growing area, and you have all heard of LLMs, which I'm going to just talk about. But from predictive AI to Gen AI is where we are trying to move towards, and everybody is talking about investing in this particular area. So, like I said, I'm going to do a level set, and then we're going to head on to the topic of the day. But AI has been around. We heard about that. Machine learning is a form of AI, and Gen AI which came in. So what made Gen AI possible was our foundation model or foundation models, right? What does a foundation model means? These are general purpose models that are trained on huge quantities of data, and then they serve you the answer. So if people who were in that room earlier, they saw a lot of examples. One of that example was when you keep asking questions, same question being asked to ChatGPT does not guarantee you the same answer back. It will respond to you different answers and sometimes even incorrect answers. So you cannot rely completely on ChatGPT or or a foundation model as an instance, because foundation models are non-deterministic. It means that they do not guarantee the same answer, even though you may be asking the same question again and again, using ChatGPT or whatever model you are having. So keep that in mind. Now LLM is so we have a so what companies are doing then, they are training these models on their specific data, right? They keep on training them to make sure that the outcome of the model is pretty precise or accurate to a great extent. And Now let's look at that. I'm going to jump to this part, right? So now, when you have a model, you want to train that model so that you can get a business outcome. This is the very important part which we got to understand. There are different ways to tune or train your model, and the complexity increases based on what technique you end up using. Right? So you, like I said, you have ChatGPT today, which you are the most familiar with. It has, it's using the underlying model, which has been trained on a lot of public data up to a certain time. After that time, it has no knowledge about what happened, which means that if you asked a question, the response may be incorrect or totally irrelevant. It will continue to keep responding you hallucinations, right? Or keep giving you incorrect information. So essentially what you're then trying to do is you're trying to apply different techniques to train that model to fit your particular use case. So, as an organization or as an individual or a research scientist, you may be taking that open source model, right? You bring it, bring it in your own environment, and you say, okay, this model has been trained on certain public data up to a certain point, but I wanna take this model as my baseline, and I wanna work on it, train it, to fulfill my particular use case. What technique would you like to use, right? And that's what I'm trying to kind of showcase on a high level here. For example, there are 4 different ways written here. If you see the rightmost, which is build from scratch, you absolutely could build from scratch rather than taking a model from open source community, but that would be very complex, very expensive process to do it, and it can cost multi-millions of dollars and a lot of time. So maybe that's not something you want to do. Fine tuning could be another technique, which would again be very expensive, time consuming. Quality of that would be better, of course, but it once again, expensive, right? So depending on the use case, it may be appropriate for you. You may be using some other tuning techniques like prompt tuning as well, right? You prompt it in a certain way by doing prompt engineering, that your output starts to come out to you. Now, RAG is a technique that we are talking about today. So what essentially RAG means? RAG means that Retrieval-Augmented Generation. This is the subject of the day. So essentially what that means is, think of it like you are going to give data to your model, but that particular data will not change the underlying model. It will not change the DNA of the model. It will just augment it. So think of it as a trailer you will be hooking behind the truck. So truck stays the same, but now you have additional load carrier sitting behind you, and you can of course unhook it and hook something else, or you can hook a bigger trailer. Just think of it the way you would like. But the point being, very fast, very effective, and essentially cost. There is not much cost to that as well, and the outcome will be very precise. The reason that it would be very precise is because it's augmentation. So you have a model. Earlier, what you're doing is you're feeding a data to the model to train it, right? You're trying to change the DNA of the model. So it's very expensive, time consuming, and then you will see the output, and then you will realize, oops, maybe it's working, maybe it's not working. So you're going to do that job again, you're going to train it again. Now, how about I tell you this thing? You have a model, and rather than training the model on all this different data, why don't you feed about your, as an example, company financial information, which is written in those 10K documents which you filed with SEC for last 25 years. Now that information is already documented, right? So you just attach those documents with the model, right? And then essentially what is happening, whenever somebody asks a question, model will say, okay, I know I need to look into these documents, and I can pull pretty precise information from that document and give it back to you. So more or less like, it's search and query, and that is what makes it cost effective, precise, and super effective. So there are a lot of business benefits to that. It will improve your search relevance. It will help you with personalized recommendations. You can create content also. By the way, for example, you can even do it on ChatGPT as an example. If you go to ChatGPT, there is a way to upload a document somewhere, I believe. Oh, here it is. Attach file, connect to Google Drive, upload from computer. You can even upload a document as an example here. For example, I'm uploading this particular document right now in front of you, and essentially I'm feeding my own document. It looks like you have uploaded a blah blah file. How would you like to proceed? So you can imagine that the model has been fed this particular very specific document, and whatever question I will ask, it will go and read in that document and give its analysis on it. So this is one way that you can you can realize the potential of it. Going back to my slides, how does this process works in enterprise or a complex use case? Because when you're working in a healthcare company or when you're working in a financial institution, you are not going to use ChatGPT, right? You probably will be prohibited to do that. And you're not going to be allowed to upload your financial documents or patient-related clinical data on ChatGPT, because then you will once again be in trouble. So you will be having your own model, and on that model you will be uploading probably your own company documents or your proprietary information or whatever that might be. How would that work essentially? You will load your data. It's like 3 or 4 step process. Load your data. So you're loading or uploading your document. What that does is then it splits those documents into smaller chunks and then stores and index those splits for better search criteria. So it uses a vector store. So think of like you can even use Postgres database. That's where it stores all these chunks of little data, and you then come in and start to do search or ask questions. So basically, retrieval of retrieval of that information will start to happen. So you will ask a question, and like I said, the LLM will say, okay, I'm supposed to, the question has been asked to me, and I'm supposed to also see in the vector database if I already have an answer to this question, and very likely you will get pretty relevant, precise answer. And what does that mean? I'll also tell you. So let me just jump in the code. So what you're looking here is, as an example, a Python file which is for you as a data scientist. And remember, there were 4-step process. You load your documents, you then split the document, you then store the document in smaller chunks, and then later you do retrieval on those documents. So essentially those 4 steps happen. In the meantime, the indexing of that information also happens. So obviously, like anything in technology, there is always a trade-off. Just because you uploaded a document and it's going to read and process it, it also depends on how great of an indexing happened for better search. That's one part of it. Second part is when we are uploading these documents, how the format of the document was like, because if it's a text format, it's easy for the model to consume it, ingest it, store it, or if you had a lot of tables, a lot of images and stuff like that in a document, so things will start to vary based on the content of that. That has been my experience. So I'm just going to show you very quickly what is happening in this particular Python file as an example. So obviously, there are certain libraries that you see here, LangChain and whatnot. That's all fine, right? the real magic starts to happen right here. So for example, documents. So I'm trying to upload here multiple documents, release notes, whatever the, the headline of a particular document is, you can mention it here. You can mention, where is the location of those documents, the URL of those PDF files or Word documents. You can just mention them here. Once you run, you run this particular piece of code, you're loading those PDF. Further, you are storing them in this particular folder here, which they get created right here once you run or execute this piece of code. And you also give reference to additional information. So for example, you have this particular document and you may have your own company URLs. You may want to give URL to URL link of those documents right here in the notebook as well. So basically, you're just giving extra references. And then ultimately, remember, we load the document. So we have done that particular task right there. And after that, what we do is we merge the PDF doc and the website doc, which is kind of a good exercise we are trying to do. Later, you do splitting. You split those documents in small chunks for storage, and you then start to create the index on it, so there is a better search or a relevant search that starts to happen. So you're doing all of this thing in your Python notebook, and after that you do your test query to see how the result looks like. So I'm just going to do one small example for you just to showcase you. Run my notebook basically, right? This requirement is already satisfied. Further, I continue to load additional libraries of LangChain framework. Then I go ahead and load a particular, so for example, I'm going to delete this folder right now. Right? So now if you see, I have a model, right? Whatever Llama, Mistral, whatever you are using, and on top of that, I have, I'm working on this particular Python file to, implement RAG technique by bringing in additional document, and I'm trying to upload this document. So I have given the path, and I run my part, and in few seconds, we will go ahead and here you go, the folder just got created, and then the PDF also was uploaded in my Python file, right? So that happened. So I have done my ingestion. I have ingested the metadata. I have also loaded, some additional information, some public URL or a website. And then now that my document is ready, I'm going to do the splitting of the document for better search technique. Because if you remember from the last slide, there are 4 parts to it: load, split, embed, and store. So we are doing that in this piece of code. So the splitting happened, some cleanup, some additional housekeeping techniques, and then we are also doing embedding of the data, and ultimately we reach to the last stage, which is run the query. Okay, so what happens once you upload the documents, it takes quite some time to do splitting and indexing of it. So the results don't come, immediately after. However, this is how the process works. As you can see here, you can also do some testing within the code itself. So for example, it starts to show you scores like 0.99, which is a very good score when you ask a question. So, this is one of the example, but in the meantime, let me show you something. So, this is a window where RAG technique has been applied to the chatbot, and this is the window where there is no RAG technique has been applied to the chatbot. Now, if you see here, when I ask the question, what is the latest version of OpenShift AI self-managed, the known RAG version says, I don't know what you're talking about. in so many words, that's what it says. But when you go to the RAG version where the document has been fed, when you run the same question, it says, okay, so this is what happens, right? Earlier it was giving me an answer based on the context provided, blah, blah, blah. These are the 2 documents that you have uploaded. This is the answer. So like it happens in, when we are doing demos and stuff, indexing breaks. But my point being, as it, we keep on doing experiments and stuff, so don't worry about that part. But essentially with the RAG technique, you are uploading any documents that you want and you're making your LLM models more intelligent and more precise. And it is very cost effective, and you can basically make your models effective on, in a very short time frame and reduce the hallucinations. So, any questions? This is how the architecture of this looks like. And I think one additional thing I would also like to highlight, as you see more and more organizations or people are implementing Gen AI or trying to implement Gen AI, but you would see that to make them more effective, to solve their real life use cases, the very first thing they are implementing is RAG technique, because that is the most effective technique for them to make something useful out of it, rather than relying on some model that has been trained on certain data which may not be even giving a correct output. RAG is creating an immediate impact. So very important, very valuable technique. So the key takeaway for you is, when you think about, I want to do something with Gen AI, I want to do make an impact, the very first thing you should learn is, how can I implement RAG with Gen AI so that I can produce something of value which doesn't hallucinate and it is also cost effective. All right? Thank you so much.